Hello everyone and welcome to the 10th tutorial in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. In the last tutorial I discussed about arrays and I discussed about type promotion. I also discussed about operators in Java, but I discussed about it in a very brief manner. So in this tutorial, I am going to discuss about operators in Java in more detail. So let's get started. Before I talk about operators, first of all, we need to understand, two concepts. So first concept is unary operator and the second concept is binary operator. So what is unary operator? Unary operator are those operators which require exactly one input. Okay, or you can say operand. Okay, operand is a kind of input which is given to operator and it is going to operate on that particular input and it is going to produce an output. So if I talk about unary operator, okay, here I have given three examples here. So one is plus plus, plus plus, that is an increment operator, minus minus, that is the decrement operator, and minus it is a unary unary minus operator. Okay, it is not a subtraction operator. It is very, very important to remember that this is not a subtraction operator. Subtraction operator, this is actually, it is going to be a binary operator. But this minus operator, this is a unary minus operator. Okay, so it is going to make a number negative. So we are going to discuss about this in detail in the next slide. But it is just important to remember that these operators require exactly one input and they are going to operate on them and they are going to produce an output. And binary operator, these are those operators which require two inputs. Okay, so they require two inputs, or they require two operands, and they are going to operate on those two inputs, and then accordingly they are going to produce the output. So, for example, I talk about plus, then minus, multiplication, division. Obviously, if I have to use the addition operator, I need to, use two numbers because I can add only two numbers, right? So because of that reason, plus, minus, all these are going to be binary operators because they require two inputs. So now let us look into let us talk about arithmetic operators. So these are the arithmetic operators. The list contains around 12 operators. So let us look into each of them one by one. First of all, I am going to talk about addition operator. Okay, as the name itself suggests, addition operator, it is going to simply perform basic addition, simple addition, mathematics. Okay, like for example, I want to add two numbers, then this addition operator, it is going to do that. So the syntax is going to remain the same, just like when you are doing in mathematics. So here I have written 2 plus 3 equals to 5. However, in a program, it is going to be Java program, it is going to be slightly different. Like for example, you need to create three variables. So two variables will be the operands, okay, on which this particular operator is going to work. And the third variable, it is going to store the value of the result. So like for example, I can say int abc, okay, a equals 2, b equals 3. Then after that, I'm writing c equals to a plus b. So that is how the addition operator is going to work. Okay, so I will be explaining this in more detail when I use the IDE part, when I use the IntelliJ IDEA. So right now I'm just giving a brief introduction to those operators. Okay, so now subtraction operator, again it is just the opposite of this operator. Okay, so instead of the addition, it is going to do subtraction. Okay, so like here I can say c equals to a minus b, then it is going to do the subtraction. Like I can say here I have written 2 plus 3 is 5, that was for addition, and in subtraction I have written an example here like 35 minus 23 is 12. It is just basic mathematics, it is nothing very serious. So that is why I'm not going into a lot of depth, but I will explain it in more elaborate manner when I use the IDE. So then multiplication operator, like when you're multiplying two numbers, like for example here I've written 25 with 25, I multiplied 25 with 25 and the result is going to be 625. okay, and I multiply 20 with 10, the result is going to be 200. So this star, okay, the star operator, it is going to be the multiplication operator. Then after that, I'm talking about division operator. Division operator is this slash. Okay, so like when I divide two numbers, like I'm dividing 100 by 2 here, then the output is going to be 50. Okay, so it is basic mathematics only. So these operators are actually very easy. So now one thing which you need to remember is that here I'm dividing 100 by 2. Okay. However, if I divide 100 by 3, then what is going to output going to be? The output is going to be 33. Okay. Unless you're using a float or a double. If you're using an integer data type to store the result, then 33 is going to be the result which is stored in those integer data types. So now I am going to talk about modulus operator. Okay, so modulus operator, it is going, what is this modular operator going to do? First of all, it is going to divide 257 by 3. Then whatever the remainder is coming out of this particular division, that is going to, it is going to return that. Like for example, here I am dividing 257 by 3. Okay, so we can do the division, right now. 25 divided by 3, it is going to be 8. Okay, it remainder is going to be 1. Then 17 divided by 3, okay, 3 5s are 15. So the remainder is going to be the 2, and it is going to return that particular 2. So whatever remainder comes, when I divide one number by the other number, then that is going to be the modulus operator. Now, increment operator. What the increment operator is going to do, it is going to increment or increase. Okay, it is going to increase the value of a particular variable by 1. Like here, I have returned x equals 18. Then after that, I am doing plus plus x or x plus plus. Okay, so if you already know fundamentals of programming like operators, if you studied in other languages, you will know that this is a pre-increment operator. Okay, this is post-increment operator. So this concepts we'll be discussing later on, but this is how the increment operator is going to work. It is going to simply increment or increase the value of a particular variable by 1. Okay, so if it is x is 18, then doing plus plus x, it is going to yield the result of 19. And similarly, here I'm doing x plus plus, it is also going to yield the same result. Then decrement operator, it is minus minus, so it is going to be just the opposite of this one. Okay, so instead of increasing the value, it is going to decrease the value of a particular variable by 1. So here I have written y equals 10, so minus minus x means the output is going to be 9, or even if I do x minus minus, then it is going to yield 9 as the output. So then after that, addition assignment operator. Addition assignment operator, it is denoted by plus minus. Okay. So now what the this operator, it is going to work little bit differently. So like for example, here I've written x equals to 25. Okay, and here I'm writing x plus equals to 2. Okay, so this thing, it is equivalent to x equals to x plus 2. Okay, so instead of writing it elaborately, we can simply shorten it and write x plus equals 2. And whenever the Java compiler it comes, it is going to encounter such kind of operator, it is automatically going to perform that particular addition. X, it is going to expand this expression. It is x equals to x plus 2. Then after that, it is going to perform, like for example, at the end of this statement, output is going to be 27, x equals to 27, because this is going to be expanded to x equals x plus 2. All right, so left hand side x is going to remain the same, and in the right hand side the value of x is 25, so 25 plus 2, so the value of x becomes 27. Okay, so this is how the addition assignment operator is going to work. So instead of writing this thing in two complete statement, like first of all doing the addition, then after that assigning the value. So this addition assignment operator, it is useful that it is performing both addition and it is assigning the value in the same line. So that is the advantage of this addition assignment operator. And the subtraction assignment operator, it is also doing the same thing. If you understood this concept, then it is going to be the same thing. So the x minus equals 2, it is going to get expanded to x equals x minus 2, and x equals 25 minus 2, the output is going to be 23. Okay, so the same concept will be followed in multiplication assignment operator. Like here I've written x equals 100, like 100 multiplied equals 2. So this will be expanded to x equals x into 2 or multiplied by 2, and x will be equal to 100 into 2, which will become 200. So the output will be 200 in this case. Now division assignment operator, it is going to be like here divide equals to. So here again the concept is going to remain the same. The output of this is going to be 50, 50. Okay, so again this is going to get expanded to x equals to x divided by 2, and x will be 100 divided by 2, which is 50. So then modulus assignment operator, this is modulus then equals. So this thing will get expanded to x equals to x modulus 2. So x equals to 100 modulus 2, and the output is going to be 0. Okay, because 100 is an even number and it is fully divisible by 2, so output is going to be 0. Okay, because in modulus it is going to return the remainder. So this was all about arithmetic operators. This is very simple actually. There were about 12 operators, arithmetic operators. So now let us go to the next part. Bitwise Unary NOT. So Bitwise Unary NOT. Now, if you have studied digital electronics, you would have studied about negation operators, right? So this is exactly what this thing is doing. Okay. So if you give an input of 0 to this particular operator, it is going to return 1. And if you give input of 1 to this particular operator, it is going to return 0. So it is simply going to negate it. So if we are giving 0, it becomes 1, and if you're giving 1 as the input, output is going to be 0. So that is how this operator is going to work. Then next thing, bitwise AND. Okay, now this thing again, if you study digital electronics, this concept would be even more clear to you. So bitwise AND, what it is going to do, it is this AND operator. Okay, AND operator, it works in such a manner that when both of the input are 1, then only it is going to produce an output of 1. So here you can see both the inputs are 0, output is 0. Okay, here only one of the input is 1, again the output is 0. And here a, again only one of the input is 1, output is 0. Here both the inputs are 1, then the output is 1. So AND operator, it is going to simply work on the simple principle that only when both, it is going to produce output 1 only when both of the inputs are 1, otherwise it is going to simply produce 0. Okay, then after that, bitwise OR. So bitwise OR, it is denoted by this symbol. Okay. So now this thing, it is slightly different from this thing. Here the output was 1 only when both the inputs were 1, but here the output is 1 when either of the input is 1. Okay, and even if both the outputs are 1, it is going to produce 1 only. Okay, so here we see that both the inputs are 0, so output is going to be 0 because none of the input is 1, so it is going to produce 0. Here we are seeing that here in the first case, in the second we are seeing that b is 1 and the output is going to be 1 again, and in the third case this is actually a truth table. So the thing which I showed in this slide and which I'm showing in the this slide, this is all about truth table. Okay, so when both the inputs are 0, it is going, this operator, it is going to produce the result of 0 when either of the input, okay, whether a is 1 or whether b is 1, when either of the input is 1, it is going to produce 1, and when both of the input is 1, it is going to produce 1 only. Okay, so the difference between this operator and this operator is that when either or both of the inputs are 1, it is going to produce an output of 1. Then bitwise exclusive OR. Okay, we can even call it as XOR here. So this is denoted by this symbol. Okay, now this is slightly different from this OR. So here the what concept is followed, that when exactly one of the input is 1, when exactly one of the input is 1, it is going to produce the output of 1. Okay, so now let us look at the truth table and try to understand it more better. So both the inputs are 0, output is 0. Okay, now here only one of the input is 1. Okay, here A is 0 but B is 1, output is 1. Here only A is 1 but B is 0, so output is going to be 1. When here both of them are 1, okay, both inputs are 1, so output is going to be 0. Okay, so this XOR operator or exclusive OR operator, it is going to produce an output of 1 only and only if exactly one of the input is 1. If both the inputs are 0, then also it is going to produce 0, and if both the inputs are 1, then also it is going to produce 0 as the output. Now we are going to talk about the left shift operator. Okay, so this is denoted by this particular symbol. So this is the syntax which we follow for that for this using this particular operator. First we write value, then after that we use num. Okay, now don't worry if this thing is not clear now, because I will be explaining this with the help of the IntelliJ IDEA IDE. But one thing which you should remember is that this operator, bitwise exclusive OR, it is a binary operator because it is taking two inputs. Okay, then it is producing a single output. And this operator is also binary, and this operator is also binary. But this operator is unary, so don't get confused. So now again, left shift operator, this is also a kind of binary operator only because it is taking two inputs. First input is the value and second input is the num. So let us explore it in more depth now. So this is going to be the syntax, and here, for example, here I've given an example here. The value of x is 2. Okay, then I'm writing x equals to x, then this left shift operator 3. Okay, the output is going to 16. Now you will wonder how the 16, is coming as the output. Now, one thing which you should remember is that, whenever you're using a left shift operator, okay, now this 2, it is a decimal number. So this decimal number, first of all, it is converted to a binary format, okay, and if I convert it to binary, what is going to be the, output? Like for example, 0010, okay, so 0010, that is going to be the binary version of 2. Okay, so now if I shift that x 3 times to the left hand side, what is going to happen? Okay, when I shift it 1 times, the output is going to be 0100. Okay, when I shift it 2 times, the output is going to be 1000. Okay, and when I shift it 3 times, then the output is going to be 10,000. Okay, then after that, once again, if when you convert the binary back to decimal, the output is going to be 16. Okay, so that is how the output is coming as 16 here. So you can simply, if you don't know how to convert a binary to decimal and decimal to binary, you can research on that and you can understand how to convert it. So this was a very simple example, so that is why I did it in the mind itself. But however, if I take a very large number, then you cannot do it in the mind. Then okay, so this was the basic concept how it is going to work. So now why it is left shift? Because bit, first of all, it is converting to binary, then after that the bit, that one bit, it is shifting to the left hand side. Okay, that is why it is called as a left shift operator. Now, and one another thing which you need to remember here is that it is going to preserve the sign. So here I'm writing x equals 2, the output is going to be 16 plus 16. Here if I write x equals minus 2, it is going to produce output of minus 16. Okay. Now right shift operator, okay, this is going to work almost exactly the same only. Okay. So here the syntax is going to be num, then after that value. Okay, So here I have given an example in much the same manner like I gave an example here. So x is going to be 32. Then after that I'm writing x equals this x, then this particular right shift operator 4 times. Okay, then output is going to be 2. So again the same concept is being followed here. So 32, if I convert 32 to binary, okay, so the output is going to be 1 followed by 5 zeros. Okay, 1 followed by 5 zeros. So you can basically call it as 1 lakh, but that is how the binary, that is going to be the binary version of this 32. So then after that, if I shift it 4 times, okay, after I shift it 4 times, what is going to be the output? Now remember, I am shifting that 1 to the right hand side. Okay, here I was shifting that 1 to the left hand side, but here I'm shifting that 1 to the right hand side. So initially the output, initially x is 1 followed by 5 zeros. Okay, so when I shift it once, it is going to be 1 followed by 4 zeros. Okay, when I do it 2 times, when I do it the second time, I mean, it is going to be 1 followed by 3 zeros. Okay, when I do it 3 times, it is going to be 1 followed by 2 zeros. And when I do it 4 times, it is going to be 1 followed by 1 zero. So it becomes 10 basically, 1 zero. And when you convert 1 zero to decimal, then the output is going to be 2. Okay, just like I explained it here. So then here again the same concept is being followed. It is going to preserve the sign. If I put x equals to plus 32, the output is going to be plus 2. Okay, similarly if I give input as minus 32, the output is going to be minus 2. Okay, so now unsigned right shift. Now here there is a difference between this operator and there is this operator, because this operator, only two greater than signs are there. Here three greater than signs are there. Okay, so what is the difference between this operator and this operator? So that is going to be the next question which is going to come in your mind. So now let me explain that. So the syntax is going to remain almost the same. Okay, only difference is going to be the three greater than operators. Okay, now here the difference is going to come into the picture. It is not going to preserve the sign. Okay, so this operator, it is going to preserve sign, but this operator, it is not going to preserve the sign. Okay, so for example here I'm writing x equals to 128. Okay, so I am doing x, and I'm sorry, I am shifting x 4 times to the right hand side. Okay, so here the output is going to be 8. Okay, same concept is being followed. Now I'm not going to convert 128 to binary, so you can do that from your end. You need to research how to convert binary to decimal and how to convert decimal to binary. Okay, so but where first of all I'm going to convert this 128 to binary. Okay, then after that if I shift 4 places to the right, output is going to be 8. Okay, so here the output is going to remain. Here the sign is going to remain almost the same, because here I'm using plus sign. So here if I give 128 as the input to this operator, and if I ask this operator to shift it 4 times to the right hand side, the output is going to be 8. However, here is where the difference is coming into the picture. Here I am giving minus 128 as the input to this one minus 128 as the input to this particular operator, and then I am telling this operator to shift it 4 times to the right hand side. Okay, so what is your natural reaction? You will think that it is going to produce output of minus 8, but it is not going to produce minus 8. Okay, so either you can write a Java program from your own end. Otherwise, definitely I will, in the next tutorial, I am going to take you to the IDE, okay, and then I will show you what is going to be the output. It is not going to be minus 8. It is going to be something else. So we will see what exactly the output is going to be in the next tutorial. So I am going to leave it, kind of a cliffhanger right now, so that you will find out what exactly the output is going to be in the next tutorial. So now these are the compound assignment operators. Okay, so the only important operators which you had to understand was this one. If you understood these operators, okay, this bitwise operators, then this operator is not, difficult to understand. Okay, it is the same concept, which I explained in this arithmetic operator. Like here I'm saying bitwise and assignment. Okay, like hand equals to. It is denoted by and equals to. So here I'm writing x and equals to y. It is same as x equals x and y. Okay. So I think I already explained this in the arithmetic operator. So x and equals y means it is same as it is going to expand to x equals x and y. Okay. So same for OR operator. Okay. So OR equals x or equals y. It is same as x is equals to x or y. Okay, so this was XOR operator. XOR equals, okay, you can call it exclusive or you can call XOR. Both the both the names are going to be the same only. So x XOR equals y, it is going to be same as x equals x XOR y. Okay, then shift left assignment, again same concept. X shift left equals 2. Okay, it is same as x is equals to x shift left 2. Okay, so same for shift right assignment. Okay, shift right equals, this is going, it is going to be denoted by this particular symbol, and this is shift right assignment. Okay, I am talking about assignment here. So x shift right equals 2, it is same as x is equals to x shift right 2. And at the last, this was unsigned right assignment. So I'm talking about this particular operator. So shift unsigned right assignment is unsigned right equals, okay, then x unsigned right equals to 2, it is same as x is equals to x unsigned right 2. So all this operators will be more clear when I take you to the IDE and I explain the concept with the help of the IDE. So that's for all I have to explain in this particular tutorial. So in the next tutorial I'll be taking to the IDE, and I will be explaining these concepts, like we have studied about arrays, we have studied about operators, we have studied about type promotion and all. So I'll be explaining all those concepts with the help of the IDE. And so that's all I have to talk about in this tutorial. Okay, so in the next tutorial, as I said, I'll be taking to the ID. And if you have any questions regarding this particular tutorial, then don't hesitate, don't forget to post in the comment section below, and I will see you in the next video. So till then, bye, and stay safe.